Hey everyone, welcome back to the live stream tonight. And I've gotten to a point where I need to come back, circle back, and start doing cable management. And if you guys are doing your own van build and cable management is something that you just don't want to deal with, this might help you. So you can see that I have a lot of stuff that's disorganized at the moment, needs to be cleaned up. So I'm going to go through that process. But there's also a lot of fun things that we're going to be doing. I finished building the acrylic panel for our battery box back here, and it looks awesome. I've already put in the LED strip just temporarily just to see what it looks like. I'm wondering if I can just turn the light off real quick, and then you guys can just see what it might look like. But it's really cool. So when you have that etched glass in there, it just absorbs that light, especially when you have that LED firing straight down, and it illuminates everything really cool. It's subtle, but it makes a big impact. Now we're just doing it on the back side. The forward side, where the heater and the other batteries are, that is going to be closed off, because not only that, but we have, on that side we have our breaker that's going to be installed. So let me pick that up just so you can see that too. That's going to be coming up in a future live stream. It is a Blue Sea Systems 120 volt AC breaker. So it looks something like this. It's very compact. I really like to use it because typically you're not going to have more than 4 circuits. So you say you have, you've got your microwave, you might have 2 outlets, and then you have some other connection like your hot water heater, for example. And these are really cool. They're just super easy to turn on and turn off. They have individual labels that are backlit. So you get like a whole book of, you know, microwave, forward outlet, even refrigerator or something like that. So you can put those here, you get indicator lights. It's just a simple breaker. Now this is actually going to go forward right underneath the battery and to the rear of the heater box area. And don't worry, we're going to have everything shielded in there, and yeah, just nice and neat. So this will be in a future item, but just check this out because this is a really cool component. Nice low profile. If you're looking for a low profile 120 volt breaker. All right, so the next thing we're going to work on is, let's talk about our thermostatic switch. So I'm going to hop on the computer so you can see a zoomed in view of this. I'm going to clean all my tabs up here. All right. So this is the part that we're talking about. And guess what? It is on the DIY Van Build cheat sheet, so it's under electrical. If you guys are wondering what the DIY Van Build cheat sheet is, it's a curated list of over 250 items that I've personally put together, and it's completely free. So you get this list. It's good for getting started if you don't know where to start with van products, and you want to look at a list that's actually been vetted by somebody, especially a builder. So this is stuff that I've all bought from Amazon. Most of the stuff has came in the shop, either gone into a build or is awaiting a build, and it's all on that sheet. It's organized, it's easy to find. Like up here in the right-hand corner, I just typed temp, T-E-M-P, and boom. The first thing to show up was this temperature sensor. So this list has that part on it. That's how you look it up. And then this is what we're talking about. But if you want to get this list completely free, go to vanbuilderhq.com, click the link in the description below, and you can sign up for this, and it'll be delivered right to your inbox. I really think it's going to help you out on your DIY van build. So let's check out this part. It's $11.99, super cheap, and what this is a 12 volt digital thermostat, and this is going to allow us to monitor temperature. Now you can use this for anything, temperature inside the van, you know, any type of compartment where you're concerned about something getting too hot and you need an exhaust fan to turn on. Our particular use case is we're going to be using this to turn on two mini exhaust fans to pull the heat out of the off-grid power system that's specifically exhausted by the 3000 watt pure sine wave inverter. Now it's going to be drawing in fresh air from the top of the box and going out the vent in the bottom. And this orientation has to be this way because that's how Renogy suggests that you mount the inverter. So technically we would want to mount it upside down, but in this case we are mounting it according to the specifications. So we need a little bit extra help to, when it does get, when it's being used for a very long time, we can pull that excess heat out. What I did in an earlier live stream is I actually covered this entire system, power system, with a cardboard and then did a test of this fan. And this test fan actually brought our internal temperature of the battery box down 20 degrees, and it was perfect. So it's right in the spec of what Renogy wants for the inverter not to go over, and it actually does a really good job just managing the temperature, so we're good to go. Only thing we have to do now is actually install it. So this unit, if you're looking at it, there's 4 posts here where you're going to put in a positive wire on the first one. We'll do a jumper cable in the middle between these two. And then this final one is our ground lead, which all the ground wires will connect to. And that's how we're going to use it. We've got these 3 individual switches here. And what they're going to do is you have a designated value up top, which is your I'll have to look and see which one is actually the temperature, but one's a specified temperature, and then the other one is the temperature you would that you're monitoring live. So you have a live temperature, and then the temperature you would like it to turn on or off at. So that's how this is set up. You will need to come in and pay attention to the wiring schematics for this, because there's different ways that you can wire this depending on your needs. I use this, for example, to control a AC Infinity system on the Marine One van build, and I use that to run an intake and exhaust fan for the same type of situation. We have a tight space where we need to exhaust hot air, and this thing does a great job. It's been in Thomas's van for almost, I guess, a year and a half, maybe. And it is, the van was in the shop just to work on a couple things, and it came off and on, no problem. So nice, simple board, and this is what we're going to be using. So that is the product. Let's hop back on over here and check out what are the next steps with this. So what we have here is we've got our intake. We got our exhaust fans right over here, and these are 2. I forgot the size of these, but they're essentially computer exhaust fans, and you want to look around, find out first off the footprint, what you're working with. 2, the noise. There's different versions of these. There's some that are designed differently. They're extremely loud. They're more for like server rack fans, and you definitely don't want to use that. So this is what you want to use. So we're going to cook this up. This will be the first thing we do because this is something that I haven't worked on. So we're going to take this. We've got 4 wires here, and we're going to use a Wago connector, and we're going to use a 6-position connector, so we can have 2 red wires. And actually, I wonder if I have any 4-position. I think we're using 6 because we need to get some more of these on order. But yeah, we're going to connect this. We're going to do some jumper cable and wires over here. We're going to get this working. We're going to set it to a desired temperature, and then we are going to test it. We may or may not get to testing in this video because I'm going to try to run through a couple things. If you guys have any questions during this live stream, feel free to ask them at any time. And yeah, so let's go ahead and get started. We're using a Klein tool. This is a 11061. This thing is my favorite. So it's a really easy way to strip these wires in a neat way. If you guys have ever used Wago connectors, there's actually an indicator on the side, and it tells you how much of the wire to actually remove. So I just put it on here. I take my fingernail and I kind of press in where that is, so I get a good amount of cable in here, but I don't do too much, because you don't want to do too much, you might mess up. So if you guys don't know, we recently have a new build that's going to be in the shop. The other van that you guys had always seen in the background as we were working on this van, that van has sold, and a new project is going to be put together on that one. So right now we're on a strict timeline to get this van knocked out, because I'm actively ordering parts for the van, and the first part came in today. So we got our Webasto it's like STC 2000. So we just got that in. So it's the first thing. So yeah, things are starting to happen quickly. So my goal is to, before Thanksgiving, is to get all this cable managed, put together, bolted, second panel, top panel, and then manage this air coming in and out down here. What's nice about Wago connectors is that as you're using them, you can plug the wire in, you can unplug it, and it makes troubleshooting and setting up the circuit really effortless. It helps you from not wasting a bunch of crimps and cutting wires where you shouldn't be. For example, if we had to hard crimp all these connectors and then test it, and then it wasn't the right connection for some reason, we messed up, you're going to start chopping this whole entire thing down, and yeah, you're going to start to waste a lot of stuff. I'm going to tilt the camera down just a little bit so you guys can see just a little bit better. And once again, we do have we've got the chat going. So if you guys have any questions, feel free to check it out. So this connector has a temperature probe right here, and this temperature probe is just going to go down in the bottom underneath this vent fan, and this is what is going to sense our the current temperature of what's underneath here, and it's going to send the signal. Well, first off, it's going to monitor it to make sure that either it needs to come on or turn off. And then besides that, it'll turn it on at the desired point. All right, so we got our fans connected. Next thing we need to do is we are getting some cable. These cables are some USB scrap cable that I had. I was trying to cheat and make a USB plug-in cable that was 12 volt. And the internal wiring in here, there's some type of resistor or something like that. And it will only let you allow 5 volts to come through. And I guess that's to protect the USB circuit, but it's kind of weird. But we're going to use this scrap wire. So we're just gonna cut our USB port off because we don't need it. We're going to come through and wire this up to our system. What's nice about these wire strippers is, watch this, you can quickly strip the outer jacket. And then, like I said before, with the Wago connectors, you can come in here and do your fingernail, find out the size, and then you can quickly come in, get the right amount stripped off of the wire really quick. And all you gotta do is twist the ends, and you're good to go. All right, so what we want to do is, I'm putting the wire here and I want it to go to the controller on this side. So right where this bend is where I want the wire removed, but I want to cut the wire right here. So this bend is where I want to strip it. So I'm just going to come in here. Let's see, I want to do that. Actually, probably I'll come up. Might do a little bit shorter because this one's going to actually connect to the device right there. So if this one is connecting to the device, what I'm going to do is I'm going to get my wire ferrule kit, because these terminals right here work really well if you get a wire ferrule. There you go. So this kit is also on the cheat sheet. So a wire ferrule kit, it's the most pro way to do the wiring in your van. So you see we got a bunch of different connectors, a bunch of different gauges. Just whatever you do, don't drop this, because there's hundreds. There's actually, what, like 1,000 pieces in here. So what we're going to do is we need to check out our wire gauge. So we got 18 gauge. And then right here, red is for our 18 gauge wire. And this is going to tell us, this way we can look at this and find out how much we actually want to take off of the wire. And again, I just use my fingernail to show me where I want to cut. It's the easiest method. Okay, we go back a little bit. This one. Now, like I said, we will have to make a jumper for this circuit, and it's just really easy. So one thing, if you're doing a DIY build and you want to have some type of way of organizing the mess of wires that you have in your van, is make sure you take a bunch of pictures. Take a bunch of pictures, put them into Google Photos, and what's cool is Google Photos will actually recognize this as a circuit board, and so you can just type in circuit, it'll search for the image, and then you can pull up whatever you did back in the day, so that you don't have to, worry that you forgot where you put something, crimp something. Another thing we're going to talk about in this live stream tonight is labeling your wires. So that's part of the cable management. Now this is for a future owner. So I'm labeling it so that they know what to look for, but you want to do it for yourself as well. You don't want to have a mess of wires and each one not be labeled, because if something ever happens, a wire melts. Imagine you messed up and like 2 wires crossed or something and they both melted, but you have no idea where they came from. If you label it, it makes troubleshooting that much easier, because you may not always be in a perfect place to troubleshoot your power system. You could be completely off grid. You can be out, in some park somewhere or something like that. You're not always going to be in the driveway where you can take your time and troubleshoot it. So make sure that you label everything. And make the labeling long. Just 12-volt wire goes to a refrigerator, and that this is the end of the wire, so that you know that kind of where it goes. I try to simplify this for the future owner. So what I do is I have my main system here and all my hard wiring. So all the stuff that's hardwired, such as the inverter, solar, all the big mega fuses, so all the 80 amp fuses, 60 amp, 300 amp for the inverter, the DC to DC chargers, stuff that's hardwired and that's extremely rare that a fuse is going to blow, all gets into here. And then I have a 100 amp output that goes all the way to the kitchen galley, and underneath the kitchen galley is your sub panel for all the 12 volt in the van. It's much easier to open that door underneath the sink, take the cover off, and troubleshoot some fuses than to unbolt the power system to get to things. So think about that when you're designing your power system. All right, so right here, see, we have our wire ferrules. So it's a nice and neat professional job. We've got our 2 wires over here that are going to go to our corresponding fan connections. Okay. And so that will be our power to our fan connection. So technically we only needed 3. These right here, these 2 are going to be what provides the power either on or off. So I'm going to go in here and I'm going to check my drawing. Where'd it go? Circuit. Here, okay, here we go. Yeah, so we have our power wire and then all of our grounds, and then we have a jumper. So we've got this. The first position is going to be our power supply. So I'll need a precision screwdriver to open up this first piece. I'm going to put in our positive wire. And again, the ferrules just make this super easy. Be careful, sometimes the ferrule tip is really long and this positive wire is exposed and that can create a short. So what I do is I'm going to pull this out. I'm going to remember how much extra was on there. And then I'm going to come over here and I'm just going to snip off that extra bit. So now when I go and I put the wire back in, you just keep snipping until you get the appropriate depth that you want to safely, not have the risk of short circuiting this. All right. And then what we're going to do is just give a nice tug, make sure it feels good. All right, the second thing we're going to do is we're going to wait to we're going to go ahead and do our jumper. And then we'll come back to that. Let's see what we had. Trying to go back in time here and make sure. I might have to go back on the computer. Okay, so our other positive was on the jumper side. So what this is telling me is I need to make that jumper wire. So we're just going to first, we're going to take this, we're going to strip this off. Okay, give us some, exposes us some wire, piece of 18 gauge wire. We're going to come in here and strip this. Now, depending on your circuit, I know I said wire ferrules are the best, but it is possible that I may have to eat my words because sometimes I need to fit two wires in the same, on the same connection, and it's just not possible. The ferrule just gets in the way. So one of these sides is going to have a ferrule because it's the jumper side. And then the other side, I'm not going to put a ferrule because I need to stuff two wires in there and then I need to twist them. So sometimes you have to do that. When I first did this thermostatic switch, I thought it was really complicated. I was kind of worried because, you know, as a builder, I want to sleep at night. I want to make sure that this circuit's going to work when it needs to. And after, you know, going through the drawing and kind of designing it and messing with it a little bit, it's really straightforward. It's funny how some things you get overwhelmed by, but when you get done, it's just like, oh, that was no problem. All right, we got our jumper. So the next step is we need to get our power wire. Okay, let's see, make sure I'm doing this. So you always want to take a bunch of pictures. So that's power out, that's power in. So the jumper, so we're gonna go to the computer just to double check that this part that I'm looking at is power in. So let's jump over here. Let's go to this chart and jumper right here. So this bottom right section, this is what we're looking at. I'm trying to see if I can zoom in as much as I can. So we have a positive going to the fan. So this is what's operating. So we connected the fan. So we did that. Did a good job there. We've got the jumper. So this jumper is here. The VCC is our 12 volt power supply. So here's our 12 volt power supply. So just think of this as your battery. And we've got a positive, negative. So the power coming in is going to go into that one, which is the third one. The first one is power to the fan. Second one is jumped to the third one. And then the third one is the power coming in. And then another one is just negative. So we're good. Let's keep going. Let me change the camera. Okay, so where were we? We need our power coming in. Okay, so we did that. All right, so the power coming in, I'm going to steal that from the red LED. So that was more for show, so you guys could see how cool this was. But now, so the way I do this, if you're wondering, we might go back to this later in the stream, but the channel of the 80/20 up here is open, and you can stuff with the adhesive on the back end. You can stuff the LED up there, and it's really incognito. Looks super cool. So now I'm going to go up to a predetermined circuit I have up here, which is a 5 amp circuit. I'm going to disconnect it, and now the light's off. And so now I know that this wire that I have here, that's my power supply. This one will now be my power supply for this ventilation fan. So I'm going to go ahead and neatly bring this wire down. Make sure we get some really nice cable management down here. It's a really tight space in here, as you guys, if you've been following the build, you guys know this is super tight. But what we wanted to do is maximize our everything in the van. We wanted to make sure it could have as much room. We wouldn't have a lot of dead space that's being unused. I see a lot of vans that have really big open battery boxes, and I don't think that's a bad idea, but there's just a lot of unused space. Okay, so we got this coming down. We can zip tie that there. And we just come on battery. Okay. So now we have our power input. So this is our power input cable. And so now what I got to make sure I do is, so I'm wiring this for real. It's not like this is not a demo for the van, but so what I'm doing here is I'm going in and I need to make sure that when I finish this, I can put the unit back in here, because I actually want to mount it right here, just like that. So I want to mount it, and so you can see it through the plexiglass, and you can see the temperature that it's turning on and off. So I need to make sure that everything is coming through this this window over here. All right, so we got power in. Oh, another thing, while I'm messing with this board, because this board is so cheap, it's not mounted to anything, so all the terminals are back here are exposed. So you can easily short circuit that if you're not too careful. All right, give me 1 second, guys. I'll be right back. I'm just going to get a pair of scissors. And we're going to take this electrical tape and we're going to make a little bit of an insulator on the back of this board because it is not insulated. Or something like that, which I'm actually going to do. You can just leave this on there. That's what I'm going to do. I just need to be careful because I have this metal rear trim piece and I don't want it to contact. Okay, so we got our board and we're moving to our power supply. Okay, for this power supply, we're going to put ferrules on here. So I think we're 18, yeah, okay. So now we got to see if the power supplying this can fit in here with the extra wire. Because if you remember, we didn't have that much room in here. So let's go ahead and put our jumper wire. We'll stuff it in there first, and then we'll put the one with the ferrule in there. I did the same thing for the two negative wires. I don't know if those will fit in there. We'll try it. If it doesn't work, we're gonna have to trim these off. We're going to go ahead and just trim the bottom one off just to make things easier. All right, get some more people in the stream. If you guys are just joining, what we're doing is we are wiring in a thermostatically controlled switch for our exhaust fan on our power system, and this is going to help regulate the temperature inside this box. This stuff up in here. So we're doing this switch first. We got this custom circuit board right here that we bought off of Amazon, and this is going to control the fan when it turns on and off via the temperature from a temperature sensor on the inside. Then we're going to hook up, we had an LED strip going for our frosted panel over here. So we finished this up the other day. So this is our custom etched glass panel that's going to cover the power system. That way you can look at the power system and it just looks cool. Right now what I'm doing is I'm just connecting the last wire here, and we'll actually be able to test this. Let's see here. It's going to make sure that I get enough in here for the ground lead. My only issue is a very tight circuit. The chat is open for questions, so if you guys have any questions, van build related, happy to answer them for you tonight. So you guys can just put that in the chat. Okay, we've got everything connected that we need to have connected in here. There's a fuse circuit up there. We got our control board. So now, we're just gonna send power to this and see if it works. Let's do it. There's no off and on switch, so this is going to be permanently on. Okay, the good news is nothing melted. We've got our temperature probe in there. It's measuring 71. 60, 70, 80. So what I did is I cycled through, and at 80 degrees, it's now turning on. The fans are turning on. So, I mean, it's pretty cool. It's you can see. Now, if I do a micro adjustment on the left, 79, 78, 77, 76, 75, 74, 3, 2, 1, turns off. So very nice. Yeah, this thing works excellent. So I think this is backwards. It turns off when it gets to 70. Let's see. I forgot how I do this last. $70. I want this to turn on when it gets to, let's see here. All right, so that's 70. All right, 72. So I'm gonna pull the sensor out and put it between my fingers, and we're gonna try to heat this up. Let's see, set. All right, so let's go and look on the computer, figure out how we set the other one. All right, let's see if this can make sense here. Okay, it's in low temp right now, so we need number 2. We need number 2 setting. POH 4, 5. Hot, cold. So it was on heating, so it was acting like this is a heater, but we need this to be a cooler. So we set it, we hit the set button, and then we changed it to a cooler. So now it's 75, it's set at 72. So if we put the temperature probe in front of the fans and we let it cool the probe down, we're at 74. How hot is it in here? 73. That's not going to work. All right, let's set this to, let me heat this back up. I'm going to change it to 74 degrees. Okay, that's something we can achieve. So right now my hands made this 80 degrees. So we're going to put the sensor over here on the fan, and we're going to let the fan cool this down to below 74. So as soon as this hits 74, it should turn off. All right, 74.9, 8, 7, 6, 5, 4, 3, 2, 1. There we go. Pretty cool. So we'll take this temperature probe and we will put it underneath that area where the fan is on the inverter. And we're just sitting it in there because the fan on the inverter is very strong. So this is going to pick up that heat, no problem. And actually what I'll do, let's see here. We could plug in shore power for a demo. But I think what I want to do is I want to move on to the other wires here. Okay, so that is this. If you guys wanted to do this temperature probe, that's pretty much how you set it up. It is that simple. Okay, next, what we're going to do is we are going to clean up this wire over here. So what we need to do is start to get these away so we can label them. The first thing that we're going to label is we have these 2 wires. So these 2, what we did is we pulled them and they are our wires for our DC to DC chargers. So we have this first one. So this is number 1. And then this is number 2 back here in the back. So this is number 1. So we're going to pull this out. We're going to put a label right here, and then we're going to wrap it up. So in this power system, we've got 2 DC to DC chargers. So this is going to be blue. This will be DC space DC CHG DC to DC charger 1, and then BT for Bluetooth. And then we're just going to hit print. Okay, we're just going to wrap this around the end of the wire, and now we know what this wire does. And so we're going to clean these wires up, we'll wrap them, zip tie them, and they're all going to hang out right here in this space back here between the battery and the inverter. And I'm not cutting them down to size just in case something happens in the future and this needs to be chopped up or accessed or something like that. Because it's not going to hurt anything being long. Everything's covered up. Can't see anything. All right, so that's our first one. And we got our second one. And so what these cables are doing is these are the Bluetooth communication. This is how we're using the Renogy M1 controller. And this is controlling that. So I'm going to move up a little bit so that my head is actually in the frame. I know that looks weird. Yeah, so we're just going to label the wires, grab some zip ties, and we'll mark off everything that we need to. And then we'll come into the LED for the power system itself. Because what I want to do that is I want to cut it to size. I want to set up the circuit for it. So what I also have that you guys haven't seen is I have a mini, I don't call it like a mini sub panel. But there on the back side of here, you have these 4-circuit, they're like a terminal post fuse breaker. And what's really nice about that is if you need a mini circuit right beside your battery system, it's perfect. It's exactly what you need. So right here, I forgot the name of it. But essentially here, I'll take this off. But look, it's just a 4-fuse circuit that mounts to your terminal post on your battery. And what I'm using it for is we have a 12-volt sense lead that needs to come down from the Dometic RTX 2000. So that's up here and it's fused. The next thing we have fused is going to be our power for the, what we're using this for. We got our voltage senses for the 2 DC to DC chargers. That's how they monitor their internal charging for the Renogy. So when it's charging the batteries, that's how it tells you know, what state of charge the batteries are in. All right, so let's see what we had. All right, let's go ahead and print this one out. And if you guys have any questions on, you know, power systems while we're back here, it's a perfect time to ask those questions. But yeah, I'm on a time crunch right now with this build, so I'm kind of doing double dipping here. We're doing a live stream, but also we're filming content for the final video that we'll have for this van, where we have all the time lapse of the build, and then we have a nice video where we're going through the systems and, you know, normal van build montage. Okay, so now where we have DC to DC charger 2 Bluetooth, DC to DC charger 1. All right, the next two that we have over here is, this is our because we're using the Renogy M1 system, I wanted to put in, and it doesn't come with a shunt, because when you use these smart lithium iron phosphate batteries, they're actually all networked together. So all 6 batteries are networked together, and they communicate directly to the M1 controller for all the state of charge. So there's no shunt in this battery system. So just for my peace of mind and monitoring purposes, to see how closely it measures the battery, I put in a Victron battery monitor. So this is the BMV-712 Smart Bluetooth battery monitor. What's nice, you can just plug this in, and then you can put it back behind here with all your cables, and you'll just pull up Victron app on your phone, and you won't have to ever see this screen. You'll just be able to see the state of charge. This whole thing will be hidden back here in the back. So we're just going to stuff that back there. Making our way, we've got this next cable, which is our 12-volt sense for the Dometic RTX. And as soon as I put the new label on here, I can take away this piece of painter's tape that's got the label on it right now. All right, so we got the Dometic. We're just going to call it 12-volt wire. Like I said earlier, you're going to be really happy that you did this, that you went through and labeled everything. Because say something happens and, you know, late at night, open up your power system and you just want to get straight to the problem. If everything is nice, neatly labeled, you can find it. And if it's something simple, just knock it out. All right, so this is our Dometic RTX wire. We're going to keep this zip tie. I'm going to trim it off. All right. We are knocking this out. Got our DC to DCs labeled, our 12-volt for the Dometic Next, we're going to move into our 2 synth wires. So we got one here, and we got one here. So these are the ones that I did not get a chance to identify. Okay, so this one is our number 2. So let's go ahead and get this one labeled up. So this is DC, 2, 12 volt sense. So this is the cable that's monitoring how the DC to DC charger is charging the batteries. And the labeling does not have to be perfect, perfect location. It just needs to be there so that when you go to put all this together, or go to, it's mainly troubleshooting. So now we know this is DC to DC 1. Let's go ahead and print, change, make that little change, hit print. And we're going to reprint that because we ran out of I knew it was going to run out, so. I know for some of you guys, this is like watching paint dry, which is probably accurate. I guess this is more behind the scenes stuff about organization. But yeah, I just wanted to show you how to do it. And it's important. All right, so that's all good. There's one more. This one right here. That goes to... All right, so this one Okay, this one is our Victron BMV 12 volt power. 12 volt sense. So Victron. Victron shunt. Victron shunt 12 volt sense. It's our last one. After this, we'll move on to the really cool red LED that lights up the etched glass. And so we'll do that. And my goal is to, before we end this, connect this switch. Yeah, it's going to be a long stream tonight, but it's like behind the scenes in the Odyssey Custom Van Shop. I think it's cool too. So if you guys have never seen what goes on into a build, this is a live example of all the work that it takes to make sure everything is connected correctly, safe, all that good stuff. All right, so let me get some zip ties, and we want to get a flush cut trimming tool for what we're working with here. All right, we got our zip ties. Flush cut trim tool is nice because we make sure that we don't have those really sharp edges. See if I put it over here. Flush cut. There you go. Any questions? I don't see any questions in the chat. It's late. I know it's late. All right. So there we go with that. Let's go ahead and tighten this other zip tie up. And like I said, we've got a space down in here that we're going to drop these. We're going to keep them loose so that just like this, if you had an issue, you can come through, cut the zip ties off. You can find your wire. You're not having to take the whole system apart to find it. It's organized. It's got a label on it. Perfect. So this one is the closest wire that we have. So we're going to put this down in here first. Okay, next step, we are going to take we got these three wires. Next step, we've got our Victron shunt power supply, which is not a big cable. That one's going to go through there really easy. All right, so for visual purposes on this these bunch of wires here. We're going to zip tie them to the Dometic RTX main power cable. And that's just going to allow us to keep everything nice and neat. Whatever you do, don't make sure you don't cut any of the wires that you just organized. That would be really bad. All right, so next we have this one. So this was our DC to DC number 1 12-volt sense. Just cut off that excess. All right, just send it right down there. Next one coming in is we've got so this one is next. This is our DC to DC 2 12-volt sense. I'm really excited that this is happening. So you guys are seeing this live. This is it. Once these get cable managed and these 2 panels go on, we're never setting foot back over here. Hopefully nobody will be going back in here. That's why we got the cool view right there. I'm gonna actually put another zip tie on here. I want to make sure that anything that I put in here, there's not a way for it to rattle. That's very annoying. Check my microphone level. 50%, so we got plenty of time. Right, so there's our next one. And one thing I'm being very sure about is that we keep this, we got a ventilation port over here for our inverter, and we just want to make sure that the wires are not directly over it. keep on going here. This is our, so now we're pulling in, let's see what we got here. This is our, so we need to bundle these separately. So our Victron is going to go inside. Do another zip tie on it. So now what we're doing is we are connecting the power supply for the red LED backlight that's going to be in the power system. So now we're getting to the cool stuff. Hopefully I have some more fuses. Guess we could check the fuse drawer. That's usually where they are. And let's see what we got. Awesome, we got one. Oh, it's blown. So we need one of those. We need a ring terminal. So right now, let's see that one. That one's good. Oh, here we go. Say 5 amp fuses are, for some reason, they're the hardest ones to keep in the shop. I guess it's because I use them a lot. All right, so what we're going to do is we're going to disconnect the thermostatic fan that we hooked up earlier, and I will come back and redo that. So now, right now what we're doing is we have a terminal fuse block. It's got 4 positions in it. One is our Dometic RTX 2000 12 volt supply. The second one is our Victron Smart Shunt supply. And then now our third one is going to be what we use to connect this wire, which will be our power for our switch for our red LED light. It's going to be super cool. This switch, when you turn it on, it's going to be located right here on the top of the battery box. And if you want to have that red glowing to show off your power system, or you just like the glow at nighttime, you can just quickly turn it off and on right here. This switch will be mounted into the top. We'll have a ventilation port for the inverter, and then out here, early in the live stream, we tested our fan. We set it to 80 degrees. Well, another live stream we'll go through and we'll test it. We'll hook up shore power, we'll deplete the batteries, we'll get this thing really hot, and we'll make sure that everything is working the way it's supposed to. All right, next up we have our ring terminals. These are number 10 for 18 to 22 gauge. We're working with an 18 gauge cable. So we're going to need 2 for our, so we're going to need 1 for our negative, 1 for our positive. When we get to this guy, we are going to let our Wago connectors do the management, all the managing there. So what we want to do here is we need to strip this wire enough so that our ground lead can go all the way to the ground over here. But our positive comes out and can connect to the positive. So what I usually do is I just measure it by hand here. I mark it, and then I'm going to take the Klein tool. This is a 11061. This thing is amazing. I love it. Check it out. You can strip the wire so you can pull it off without stripping the inside. So let's just see. All right, that looks good. Question is, see, positive, negative. Might have to do this a different way. That's our fuse positive in. Okay, this will be fine. All right, so if you have trouble pulling this off, because that makes sense that you would, all you got to do is just take these pliers and just kind of start working at this. It makes it so easy to strip the outer cable off. Check that out. All right, so now we have enough for our ground lead. So this we need to go ahead and strip and go ahead and put a lug on it. Let's put this in here. Crimp it down. So we got our ground and then our positive. I'm gonna make the positive much shorter because I don't want it a million miles long. Gonna come through and do that and put our other terminal on it. Okay, so now we have our two wires. So let's carefully hop up in here, connect our negative. Now I'm being very careful. Circuit is not on yet. We got our fuse out, but we are working with live power. I'm not going to turn the whole system off and back on because there's no reason to do that. For me, you might want to do that for you. So, all right, I'm going to use this last. Be very careful when you have these terminals back here, because what you want to do is not drop this screw. At this point in the build process, it would be impossible to recover this screw. It would be a very, very bad day. So I'm just going to take my time and make sure I get it back on here. Okay, we're going to feed our wire underneath the terminals, and we are going to end it right here. And just to be safe, I'm going to strip this back. Let's see how much I want to do that. Strip this back, and this is good practice if you guys are doing this, is just, even though it's not connected, just put a little piece of electrical tape on there. And you'll be happy, just like that. There you go. Now we don't have to worry about anything. We can hook this up, and it'll be impossible to short the circuit. What's cool about 80/20 is you can actually use the rail on the inside to do cable management. So what I'm doing is I'm actually on the opposite side of this channel. I'm pulling the wire down. So now this wire is going to come out and hide over here. So when my plexiglass is here, I don't see any wires hanging down. Because I'm really wanting to show off the power system and all the cool wires, and I don't want, anything hanging down and in the way. So right up here, I'm just going to put a piece of tape, and that's going to hold the wire in. We can come back later and clean all that up. We just need to get working on making sure that the circuit works and operates correctly. Here's our switch. We'll need to take this out to put it into the wood, obviously. But for right now, we're just going to pop that in there. And then we're going to, just pop it in there. Make sure it's turned off. You got a little set of instructions so we can make sure. What we want to do with this switch is we want the LED off. When the switch is off, we want the LED to turn red when the switch is on, circuit on when the switch is on, circuit off when the switch is off. So we'll read that and we'll figure out what we need to do to make that happen. Let me check my audio. You guys let me know if my audio is not doing well. I'm kind of back and forth. All right, first up, we need so the 1 and 2 is the incoming power. So we got, I have to look at this. All right, so 1 and 2. So picture 2 is what we want. So power, so positive and negative. Okay, so this is our power wires, that's easy. Two and 3. Blue and red are positive. These two are positive. So let's just do this one step at a time. So we're using Wago connectors to connect all this. I need to get some smaller ones. Okay, so these two All right, so this is positive in. Then we've got, that's our positive. Let's get our negative going. Okay, so now we have our positive, negative coming into the circuit. So that's handled. So next we need, so this yellow wire doesn't do anything. The blue is to the device. Negative goes to black. Okay. Well, let's try it out. So blue goes to device. Blue is positive. Yeah, blue's positive. All right, blue's positive to the device. So we got our LEDs in here. You've got our positive. And then we've got our negative. Negative is going to go to this Wago. Okay. Let's put a fuse in and hopefully it doesn't blow. All right. Okay, so it's wired wrong, but that's okay. Because we want this to be, the LED to be off, and then when we press it, well, we might leave it like that. So you can find the LED at nighttime. If the new owner doesn't like this and it's like, this is annoying, it's too bright, we can have it turn off. So there's different options. So right now we're just gonna probably leave it on because I think it's gonna look really cool. Let's just see what we need to. What do we need to do to make it turn off? The normal state is the LED light is on. So we want the normal state. Normal state, the LED light is off. So to do that, okay, so I think we just switched the blues. Let's see here. So this blue, take our fuse out. So this blue and this blue. Three is power in, 2 is now device. So 3 is power in. Three is power in. Oops. 3 is power in. This goes to the device. This one in 4 goes to the device. Okay. This one in 4. All right, let's try it. It's off. Now we want to turn it. It's on. There you go. So we're going to leave it like that. So now, it's normally off when it's off. When you turn it on, the red light turns on, lets you know that it's on, which you probably already know. But this is really cool with these switches. You can get them to do that. Yeah, so that is what it looks like. Again, guys, this is the panel that'll be going on. This acrylic panel with the etched glass Odyssey Custom Vans logo. Looks really cool. And then when you want to show off the power system, you'll just have a little switch up here. You'll turn it on. It'll make everything glow, and you'll turn it off. We'll get onto this system over here as soon as this is finished. The system on this side will have the same switch up here, but instead of turning on lights to illuminate the, like this, we'll have 2. This will be 2 switches. One will be blue. It'll illuminate the tank, and you'll have a gauge to see how much water's in there. Then you'll click the other button, and it'll be a white button. So one will be a blue LED ring. One will be a white. The white is a cargo light. So we've got these really cool mini LED cargo lights. And they'll light up the cargo area so you can see kind of what's going on in there. But it is time to call it a night. It is late. Guys, if you are still watching, thank you so much for joining me. Make sure you guys check out the DIY van build cheat sheet that is in the link in the description below. And also, make sure you guys are subscribed to this channel. I'm actually going to hop over on the computer really quick. I'll show you those 2 links. Yeah, make sure you guys subscribe to this channel. Give it a thumbs up if you liked it. Share this video to anybody that's working on trying to organize and do cable management on their power system. I'm going to leave you with 2 links here. So one, let's just hop on over to the computer. I want to show you guys the DIY van build cheat sheet. It is a list of over 250 curated items that I use in the shop. It's for my last 3 years of buying all of the stuff on Amazon, and I think it is an awesome list for you. Let's get my face back over here. There we go. So awesome list for you guys. Put your name and email address. It's completely free. So if you're looking for something to help you with doing van builds, this list is completely free. Super awesome. Again, DIY van build cheat sheet. You can find it on vanbuilderhq.com, or you can click on the link in the description below. Last but not least, let's check out Odyssey Custom Vans. And where is my website? There you go. So Odyssey Custom Vans, if you guys are looking for a professional van build, check out Odyssey Custom Vans. First, we're going to go over the van that we're actually looking at right now, which is this Ford Transit high roof all-wheel drive that we're working on the power system. If you want to do a quick tour, we took this van to Adventure Van Expo to show it off, and here's a quick walkthrough. Down here is all the items in the list about what's included in the van, all the power system, water, all that good stuff. And we got some photos just to hold you over until we do the detailed video about this van build. Here's some photos to check out what is included in this van. Again, if you guys want to contact me, here's my email address and my contact phone number. The best way to contact me to inquire about this currently for sale van, or the vans that are currently for sale on our website, you can click here. This is a link to my calendar. You can go ahead and click on a date, pick a time that's best for you, and we can hop on a phone call, talk about the current vans that are for sale or that we have for sale if this one has already sold. On the left-hand side, if you guys are interested in doing a custom build yourself, or doing a custom build with Odyssey Custom Vans, this is a little quick rundown of how to prep for our phone consultation before you guys set up a phone call. So just a quick little instructions here. You can click on the date and do the same thing, select a time to schedule. We always have future build slots that are open, usually in the next year. So if you want to go ahead and get on that list, go ahead and schedule a time to chat with me, and we'll let you know what openings we have available for a build out. Other than that, I want to thank you guys so much for checking out this live stream tonight. Hope it was helpful with all the wiring and managing everything. And if you have any questions, put those in the comments below. Click that subscribe button, click that like button, and if you have any, let's see here, ideas for future videos, I always like to ask that question. Put those in the comments as well. I read the comments. I love to see if you guys have any questions that haven't been answered. We can put that in a future live stream. But until then, we will see you guys on the next live stream.